Good morning, good afternoon, good evening, everybody, and welcome back to INE's CCI Data Center V2 Advanced Technology Series. In today's sessions, we're going to begin our next major topic domain, which is going to be storage area networking. That's going to go along with unified computing. So before we get into the specific details, technical-wise, of storage, I want to talk about from a high-level overview what we're going to be covering in this section, and then we're going to be starting first with a functional example. And I'm going to kind of walk step by step through what are the different components that are making up the storage area network, how are they interacting at a protocol level, and then from a configuration point of view, what is going to be our ultimate goal within the storage section. And then once we get kind of a general understanding of what we're trying to accomplish, then we're going to come back through the details behind the scenes, talk about how the specific protocols work behind the scenes in terms of fiber channel, FCOE, iSCSI, etc. So in general, the workflow for this section is that we're first going to be talking about just what are the components of the storage area network. So how do the storage arrays work? How do the different storage switches work? What are the differences in the models? Like what's the difference between the multi-layer director switches, the MDSs, versus the Nexus series? Within the Nexus series, what are the different features in terms of the 5K versus 7K versus 9K? And then also how the host bus adapters, the converged network adapters work on the end hosts. Okay, so all of our layer 1 physical connectivity. We'll then talk about the storage protocols. So mainly in this section, we're going to be focusing on block-based storage, which is going to be through fiber channel over Ethernet, and iSCSI. We will touch a little bit on file level storage, which would be like a network file share in NFS, or a CIFS share like a Windows or a Linux type file share. We'll then start to get into the details of fiber channel behind the scenes. How does the fabric login process work? How do the fiber channel services work, the domain services, in terms of things like the name server, the domain server, principal switch, zoning, FSPF routing, and so on and so forth. We'll then talk about quality of service. What are the differences between native fiber channel and fiber channel over Ethernet in terms of how they deal with congestion in the network, how they deal with flow control, congestion avoidance, congestion management. We'll then talk about high availability in terms of how do we replicate our storage from one data center to another, either doing active standby storage replication or active storage replication. We'll also talk about SAN A and SAN B design, which is going to allow us to do multipath input-output or multipath I/O, basically the servers having multiple routes in order to get to their disks. So if one physical interface fails or one switch fails, we're able to reroute the traffic in order to talk from the host to the storage array, or what we call the initiator talking to the target. We'll then talk about unified fabric. Unified fabric is going to be referring to running our storage protocols and our data protocols over the same physical link. So we're going to be going on a regular Ethernet interface and running both fiber channel running both data traffic, like IP traffic plus fiber channel over Ethernet. Okay, then we'll look at IP plus iSCSI when we're doing storage protocols that are only IP-based. And then finally, then we'll move into our next major section, which is going to be the unified computing system, and then talk about the details of how the UCS fits into the design, both from the standalone C-series rack mount servers, and then also the B-series blade chassis, and then how we can talk to the fiber channel SAN, the FCOE SAN, and then also iSCSI. Now, as I mentioned, before we get into the details of this, what we're going to show is a full functional example that I have built. We're going to look at the final end result of the server, which we call the initiator, talking to the disks, which is what we call the target. And then take a look at a little bit of the configuration, but just kind of get a general overview of what we're trying to accomplish. And then once we know what the final end goal that we're working towards, then we'll start back at the individual components and then work up from there. So as usual, as you guys have questions, feel free to type those into the Q&A box on the bottom of the screen. Otherwise, we will get started here in our first section. And what I want to show to begin with is going to be what our physical topology for these sections are going to be. So there's going to be two main diagrams that we're going to be referring to. The first is going to be using the UCS C-series servers, which are standalone rack-mount servers like pizza box servers, same as you would see in Dell, HP, Supermicro, whatever vendor that you're using for servers. We have these connected to fabric extenders. So the Nexus 2000 series FEXes, so we have regular Ethernet interfaces that are 2 by 10 gig ports, one that's going to Fabric Extender 1, one that's going to Fabric Extender 2. Those FEXes are then dual attached up to the parent switches. Parent switches in this case are Nexus 5672s that are running both native fiber channel and fiber channel over Ethernet, so they're unified platforms that support both Ethernet and FC, so unified ports. We have the 5Ks that attach to the storage array directly. Storage array is going to be running a native fiber channel. And then in later examples, we'll look at a second storage array that is going to be running iSCSI. Now, regardless of what variation that we're looking at in storage, whether it's file storage, block storage, or within block storage, if it's FC, FCOE, iSCSI, we can break this down into kind of three main components that we're trying to accomplish from a design point of view or a configuration point of view. And what these components would be is the first off that we need to get the initiator, IATOR, to log in. Okay, initiator being the server. Okay, server is trying to get access to its disk. The second step is that we need to get the target to log in. Okay, the target in storage terminology is going to be the disk. Okay, so the server is trying to attach to its disk. And then our main job is going to be in the middle. From a networking point of view, we need to route the traffic from the initiator to the target. Okay, so we'll see that depending on what type of storage protocol we're running, whether it's going to be native fiber channel or FCOE or iSCSI, there's going to be different steps that are going to make up these three components. But from a very basic view, the workflow is going to be the same regardless of what type of storage protocol that we're running. Now, in this particular case, what I already have configured is there's a virtual port channel, a VPC that's running between the Nexus 5Ks like we talked about before in many sections, where we have the pure keep alive, we have the pure link, we have the member ports that are actually forwarding the traffic from a layer 2 point of view. And in this case, I have the VPC configured down towards Fabric Extenders. And then the Fabric Extenders have a VPC that's going down to our end host, which is going to be our UCS C series, the rack-mount server. Now, the ultimate goal for this example is that the C server is going to be booting to the SAN, and it's going to be having two different paths in order to get to our fiber channel storage array. And from a design point of view, this is what we call SAN A and SAN B. Okay, it basically means that we just have two different paths in order to get to the same disk, like two different routes. The idea from a design point of view is that if we run into some sort of problem in storage network A, like a physical link goes down or a switch goes down, or we have some issue with the controller talking to the array itself, that the end host is going to have an alternate route, basically an alternate path to the disk, so that we're able to still send our read request and send our write request, and we don't have any problems with the data being corrupted. Now, we'll see once we get into more details with this from a low-level point of view how the actual storage protocols work. There's going to be some components that are going to exist on the server itself, like drivers inside of Windows or Linux or VMware, in order to allow us to have multiple paths to the disk. We'll see that there's going to be components from the networking point of view of how we actually route the traffic from the source to the destination. Then how do we allow the access control to say this particular server is allowed to talk to this volume of storage or this individual piece of storage. But again, what I want to show here is without getting into too many details to start, just kind of the end functional result of we power the server on, we tell it that we're going to use the disks that are attached to the storage network as opposed to the physical disks. We boot our OS that was installed to the storage array, and then ultimately we should have multiple paths, or what we call multipath input-output, multipath I/O, in order to reach the physical disk that is being attached behind the scenes. Okay, so where we're going to start first then with this example is going to be on the UCS server itself, the C200, and we're going to be connecting to the Cisco Integrated Management Controller, or the SIMC. The SIMC basically is the standalone GUI interface for the server, and this is where we're going to manage the network adapters, where we're going to manage the storage adapters. What would the details of the BIOS be? Like, am I going to boot to my USB disk? Am I going to boot to the remote SAN? And so on and so forth. So I have this pre-configured, but we're going to ultimately get to the stage where we're manually configuring this and talking about what are the different components and the details we need to change from the management controller in order to talk to the storage array. But to begin with, let's go ahead and take a look at this from a GUI point of view. And as kind of a side note here, when you guys are accessing this through Rack Rentals, the way that you're going to be doing this is connecting to your jump box through the members control panel, so through the remote desktop tab. And then when you look onto the Windows desktop, you'll see a shortcut here that says Lab Files. Okay, under Lab Files, there's then a directory that says UCSC servers. And then it shows there's 4 different servers depending on which type of topology that you're trying to talk to. So there's going to be 3 different servers that are attached to Fabric extenders, and these are going to be shared between racks 1 and 2 for server number 1, racks 3 and 4 for server number 2, and then server number 3 for racks 5 and 6. And then additionally, there's going to be a server that is directly attached to the ACI leafs. Okay, well, technically they're going to Fabric extenders, and then the Fabric extenders are talking to the ACI leafs. So we'll go through that in more details later. So how we can talk to the storage through the APIC. Okay, so can we run iSCSI? Can we run Fiber Channel, FCOE, and so on and so forth? That's going to depend on the individual release of the ACI that we're running, and then also the specific hardware of the Fabric extenders and of the leafs that we're going to be connecting physically to the network. But in this particular example, you would basically just follow the link for C200 M2 number 1, which physically is going to be the server that is attached to, in this particular diagram, N2K3, so Nexus 2000 number 3 and Nexus 2000 number 4. And then physically these guys are attached to 5K1 and 5K2. Okay, so basically just click this link, and then this should get you to the front end page for the Integrated Management Controller. It may give you an error message for the certificate, because the certificate is self-signed by default, so you can see Chrome has that error message there. But if it does give you an error, just say, I want to accept the certificate. And then you're going to log in. Okay, so for Rack Rentals, the username and password would be Cisco. Okay, in this case, I'm going to log in as admin because I'm going to be making changes to the system. And within the scope of the Rack Rentals, you're not going to need to make any changes here. The initiator and the target initiator and target information is going to be pre-programmed by me into the SIMC. But to show you what are the individual components, we need to log in as admin. Okay. Otherwise, on your end, the only thing you really need to do is just boot up the server, power cycle it, and then tell it to go to the boot menu. And then from the boot menu, you'll be able to see what different options you have, like the local disk, USB disk, virtual CD-ROM, and then hopefully the storage array. Assuming that you have the storage area networking configured properly, we should be able to get the communication from the initiator, being the C server, to the target, being the actual fiber channel array. Okay, so from here in the SIMC screen, the main page that you land on is going to give you just some general info about the box, like what is the IP address for management. Okay, so in this case, we have a web browsing session going to 192.168.0.112. You can control the server physically here, so you can power it off, you can reboot it, you can launch the KVM, okay, which in this case, I have the KVM already open here at the bottom of the screen. And what this is going to do is give you a view as if you were physically attached to the box. Okay, like you have your physical monitor plugged into it. This would be the end result. And in this case, we have a VMware ESXi 6.0 instance that's running, and it tells us the specifics of the server. This is a UCSC 200. It's got a Xeon 5600. It's got 8 gigs of RAM. And we'll be able to see, once we get into the actual vSphere client, the details of not only the server components like CPU, memory, storage, networking adapters, storage adapters, and so on and so forth. Okay, additionally, under the KVM, you'll see this tab here that is VM. This is for virtual media. And this is going to be how we attach any of this installers. If we need to reinstall VMware ESX or we need to install Linux, Windows, whatever, okay, this would be the way that you install an OS to the SAN, because when you start this in a real design and you have your storage array give some sort of logical volume for your server, when you attach the server to the array, ultimately that disk is going to be blank. Okay, same as buying like an SSD or a spinning disk, plugging it into your desktop or your laptop. Assuming that's the only disk in the machine, first order of business is that you need to install an operating system to it. But in our particular case, since we're accessing these servers remotely, I don't want to have to get someone into my data center to physically plug in like a USB installer or the physical CD. Through the KVM interface, both for the C-Series standalone servers and then also for the B-Series Blade chassis, we can connect a virtual CD-ROM or a virtual floppy disk to the servers. They're going to see this as if it was a physical attached disk, and that's going to be one of the ways that we can run the installer locally in order to get that information onto the SAN disk. Okay, but I had previously done this in another step, which was to attach the ESXi installer. But if you were to do this here, like from Rack Reynolds, the way that you would do it is go to the Virtual Media tab. You say that you want to add an image. Okay, from your Windows jump box, this is going to be under the lab files, then under ISO, and then we have our different installers. Okay, on the storage array, we're going to be running VMware, and you can see that there's a custom image for VMware 6.0 that has the Cisco drivers built into it. So this is going to be both for the standalone C-Series rack mount servers and for the B-Series blades. Okay, the main idea for this is that when you do the installer, you don't need to add an additional disk that has the drivers, okay, like the HBA storage adapters, the VIC drivers for the network adapter. Basically, Cisco VMware get together and they pre-insert or pre-compile those drivers into the installer. Okay, but basically what you do is just double-click this and then say that you want to map the disk. Okay, once the disk is mapped, then the server is going to see this as directly connected. Okay, then from the KVM, if we were to reboot the server and then go into the boot menu, we would see that CD-ROM shows up as one of the options for booting the machine. Okay, but like I mentioned, in this case, I already have that pre-configured. Okay, so then the next thing I'm going to do is to go into the vSphere client of the host, and we're going to look at some of its basic properties, see what it sees in terms of storage adapters, in terms of network adapters, and then most importantly, what does it see as its actual storage volumes? Like what are the data stores that ESXi sees in terms of booting the hypervisor, and then also running the actual virtual machines like our Linux VMs, Windows VMs, and so on and so forth. Okay, so up to this point, I have just a vanilla blank install of ESXi. And you can see that the management IP address is not yet assigned, so it's getting a default link local address of the 169.254 network. So what I'm going to do is to go into the network configuration, which is you hit F2, and you log in. Okay, the password here should be CCIEDC01 with a capital C to begin with. Okay, and you'll see this is going to be documented in the Rack Reynolds, but the username would be root, and then password is CCIEDC01. Okay, if for some reason you cannot log into the box, then you can just do the reinstallation. It only takes like 5 to 10 minutes to install. Okay, so we log in, then we're going to go down to Configure Management Network, and we're going to go to Network Adapters. Okay, in this case, we can see that the VMware host, so the hypervisor, sees 4 different NICs. Okay, it's calling these VMware NIC 0 through VMware NIC 3. And we can see that the first 2 are disconnected. The second pair is connected. These second interfaces, VMNIC 2 and 3, These are the 10 gig adapters that are physically going to Fabric Extender 1 and Fabric Extender 2. So this is where, from the SIMC point of view, I have the host bus adapters, the storage configuration, pre-configured with the correct naming convention to know where am I sourcing traffic to and where am I destining traffic to, or where am I sending traffic to, in order to boot from the storage array. Okay, additionally, once those interfaces are initialized from a driver point of view of ESXi behind the scenes, it's going to hand them off as both network adapters and storage adapters. And we'll see later, once we start to get into more details of this, this is what is called unified fabric from like a marketing point of view. Basically means that we're using the same physical cable to send both storage traffic and regular LAN data traffic at the same time. But once you send that traffic to the OS being like ESXi in this case, could be Windows, could be Linux, whatever, the OS is going to have some sort of driver that knows what traffic is storage, what traffic is regular like LAN traffic, like IP packets. The LAN traffic is going to go to the network adapter, the storage traffic is going to go to the storage adapter, and then we're going to be able to separate the traffic internally. Okay, so what I need to do here is to go back to the network adapters, and I'm going to choose one of these, the second pair of NICs. So I'm going to say virtual NIC number 2. This is going to be my management interface. Okay, so enter to accept. Next, under VLANs, we're not going to do any VLAN tagging. Okay, so this means from the network point of view that we're going to have either an access VLAN or a native VLAN, like an untagged VLAN that's going down to the hypervisor. And the next step, I'm going to configure an IP address. Okay, right now, by default, it's trying to get an address through DHCP. In my case, I don't have a DHCP server configured on the LAN, so it's getting that default link local address 169.254, just like Windows would get if it didn't have a DHCP server located. Okay, so in this case, I'm just going to set a static IP. So down to static addressing. IPv4 address is going to be the network 10.0.1.201 is going to be this guy's address, and the subnet mask is going to be /24. Gateway address is going to be 10.0.1.254. Okay, this is a subnet that I have already pre-configured on the Nexus 5Ks in terms of their layer 3 connectivity. Okay, then I hit escape a couple times. It's going to ask me, do I want to make these changes? So yes, I do. It's going to bounce the management link. And then we should get back to the main page, and it should show now that the IP address is now statically set. Okay, it's statically set to 10.0.1.201. Okay, now assuming that my regular LAN network connectivity is working, I should now be able to ping this IP address from my local host. And I'll talk about in a minute here what the rest of the network topology looks like. But let's just assume for the sake of argument, layer 2 connectivity is built, layer 3 connectivity is built. I have all my IP addressing correctly set up, so I should be able to ping to 10.0.1.201, okay, which I can. I should also be able to ping to my default gateway, which is 10.0.1.254, okay, which is working. Okay, the next step is that we're going to open up the VMware vSphere client and log into the hypervisor, and I want to look at just what are the attributes of the host itself. Okay, so we're not talking about any of the virtual machines yet. We're just talking about the physical functions of the server. And mainly what we're most interested in this example is what is the storage connectivity. So how many storage adapters does it see? How many physical disks does it see? How many data stores does it see? Like from a VMware file system point of view. Okay, so under the vSphere client, I have the address that I configured on the host. Okay, so 10.0.1.201. Username is root, and then again, the password should be CCIEDC01 with a capital C. And if this works, this connecting dialog here, it should change to loading inventory. Okay, if it is loading something, then you know that IP connectivity is working. Okay, so this is default install. It starts with a 60-day eval, so you can just ignore this, this first portion. And normally on the left here, this is where you would see the different virtual machines that are actually running on the hypervisor. But in this case, it's just a blank vanilla install. So the only thing we have right now is just the management IP of the host itself. Okay, specifically, it's called the VM kernel address, where the VMK is like the management zero address of the VMware machine. Okay, so from here, we're next going to go to summary. Okay, summary is going to tell us just a little bit about the server. So you can see it's a Cisco server. C200 is the specific part number. So it's got 4 cores of Xeon 5606. It's got 8 gigs of RAM. Okay, so you can see right now that it's not using anything because there's no virtual machines actually running. And then we see what storage it is connected to. Okay, so it's these 4 different disks, it's these 4 different data stores. Okay, so next we're going to go under the configuration and configuration to storage. Okay, so under storage right now we can see it sees, like I mentioned, 4 different volumes or 4 different disks. And some of these are physical disks that is going to an array that is called a JBOD, okay, just a bunch of disks, or a JBOD. We'll talk about the difference between JBODs and storage arrays a little bit later. And then the 4th one on the bottom is the one attached to my regular SAN array. Okay, normal SAN array being like EMC array, NetApp array, you know, all flash storage, spinning disks, you know, however we have it physically configured. But basically, the storage array is presenting some sort of logical volume to the server. The server is going to see this as a physical disk. Okay, so we see it says that we have this fiber channel disk, and it's a pretty small disk. It says it's 2.5 gigs. Okay, there's no free storage. But if we look down here under the path selection, what it tells us is that we have 2 different paths in order to get to the storage. Now, what this means is that if we take a look back at our network diagram, these 2 different paths are these 2 different 10 gig interfaces. So the basic idea is that we can send our SCSI traffic, okay, SCSI traffic being the read request and the write request to the disk that's going to be coming from the upper level OS layers. So the OS is going to say, hey, I need to write to the database, I need to read to the database. So I'm going to send that as a SCSI command down the stack to the lower layers. In the lower layers, in this case, we have a fiber channel driver running. Okay, that's going to be a VMware driver that's talking to the physical Cisco adapter. And then the fiber channel adapter is going to take those SCSI commands and it's going to encapsulate them down into the network protocol. Okay, same as like any other protocol that we're used to, like web browsing, the upper layer application makes an HTTP GET, HTTP POST request. The web traffic then gets put inside of TCP and IP at the network driver point of view. Then it ships it down to layer 2 Ethernet port, and then ultimately it goes to the switch network, the routed network, so on and so forth. Okay, in our particular case, same exact logic here. The upper layer application is going to be the SCSI traffic, the SCSI reads and writes. Those are then going to get encapsulated in the fiber channel protocol, or FCP. Fiber channel protocol, you can kind of logically think of this like TCP or UDP. It's going to be the transport protocol for the upper layer application. Okay, we then take that transport protocol, we're going to put it over the layer 2 network. In this case, our layer 2 network is Ethernet, so we're going to be running fiber channel over Ethernet, and then we send it down to the layer 1 process, so physically out the link.